Welcome everyone. I am Mark Cruz and we're going to be presenting this topic, threads and concurrency. So to first start this one, it's our contents is one, threads, benefits, multi-threading and multi-core programming, concurrency and parallelism, and multi-threading models. Threads are basically a basic unit of CPU utilization. It comprises a thread ID, a program counter, a register stack, and a stack. So basically, let's utilize this using this illustration. So the factory right here is like the CPU, the workers are the threads. This specific ID is the thread ID of these workers, the to-do list, and the program counter. The tools you can see there is the registers, and the last picture is like the workspace or the stack. Basically, each worker has their own thread ID, has their own specific task, has and share the same tools, and also they run independently in the stack, or they have the capabilities to run independently. And that is the same reason why threads have their own benefits. They are responsive. That even one thread goes down, the other still run. And of course, resource sharing, it saves a lot of memory storage because it's basically sharing the same resources. And this is economy right there. It's much more cheaper to process creation, thread switching, lower overhead than context switching. And of course, scalability, it allows for us to utilize the power of the CPU, especially for multi-core CPUs. And when we're talking about this, it's also good thing to bring about multi-threading, because multi-threading is dividing a task into smaller ones that we can run independently. And threads share the same memory and resources but work on different tasks simultaneously. So it's like the factory workers have their own specific tasks and which gets the job done. And multi-core programming, on the other hand, is much more focused on designing a software to take advantage of the CPU, especially for multi-core CPUs. So it's about maximizing the CPU's hardware capabilities. Now let's talk about concurrency and parallelism. And to summarize this, concurrency is just like handling multiple tasks at the same time, but not necessarily running them simultaneously. So think about a single core CPU switching between tasks so quickly, it seems like they're running at the same time, at once. And parallelism, on the other hand, is about running multiple tasks simultaneously using multiple cores or processors. So one good example would be a multi-core CPU processing parts of a large computation at the same time. So that's what really is the difference between concurrency and parallelism. And this model of multi-threads has a lot of models. We can talk about like many to one multiple threads from a user application are mapped to a single thread at the kernel level. So basically there are multiple threads, but it's being processed at only at one thread, many to one. One to one, it's much more of, each user level thread is mapped to a separate kernel level thread. Each thread has their own thread in the kernel level. Many to many, it's much more focused on multiple user level threads that are mapped to a smaller or equal number of kernel threads. So there is an equal number of threads in the kernel level in which processes these threads at the same time. So to summarize this, basically threads are the basic unit of CPU work, and then they are the workers basically in the factory. Benefits is the responsiveness, its scalability, its economy, its just usefulness. Multi-core and multi-threading is focused on multi-threading of multiple threads at once running. Multi-core is about designing the CPU, maximizing the CPU resources. Concurrency and parallelism. Concurrency is much more focused on managing the task, and parallelism is about simultaneous executing those tasks. And multi-threading models is many to one to one, and many to many, as we have talked about in the previous slide. And I would want to ask this question: is that in this picture above, which do you think shows parallelism? Is it A or is it B? Please comment down your answers below, and that will be a good one, an exercise for all of us. I am once again Mark Cruz, and I thank you for listening into this video. I hope you have a great day.